Okay, we are on to number 5 from the 2023 AP Calculus BC exam, FRQ number 5. Here was our KHS average, a little bit above the global average, which was a little bit above the Texas average. A pretty nice scoring problem. I would say that that's kind of average, okay, 4, 5, 4.5, 5, kind of average. And I look at this and I know that it's going to be an area volume question, yeah? Okay, so that's fully what I'm expecting. So my mind is shifting to my area and volume. Integral top minus bottom will be my area, and then all my volume is the integral of the area of a cross section. So all of those are running through my head, even just looking at that picture. Okay, the graphs of the functions f and g are shown in the figure from 0 to 3. It is known that g of x is this function. Okay, for x is greater than or equal to 0. Okay, the twice differentiable function f is not given to us, but it satisfies f of 3 is 2. So that means that this point right here is the point 3, 2. F of 3 is 2. And the integral from 0 to 3 of f dx is 10. So here's f. So they are telling us that the area under f is 10 square units. Okay? Part A, find the area of the shaded region enclosed by the graphs of f and g. Okay? Integral, top minus bottom, right? So for part A, integral, top is f, bottom is g. And we are going from 0 to 3. Easy peasy, right? Well, it would be easy peasy, but we don't know what f is, right? We do, however, know what that integral is. So I'm going to split this integral into 2 pieces. I'm going to say that that is equal to the integral from 0 to 3 of f of x dx. The dx closes your integral, so do that, okay? Minus the integral 0 to 3 of g of x dx. Just the other day, you guys, I was grading a paper, and I forget exactly. It was a fundamental theorem of calculus question, and I forget what the numbers were, but it was like this. Whatever. I don't know what it was. Okay, except they didn't put the dx there. And then they wrote this. And they wrote an answer. What's wrong with that? What's wrong with that is there's a dx implied. Whether you write it or not, anyone who's grading this is going to read a dx. Where are they going to put the dx? Well, for this one, they're going to put it right where it needs to be because it's the last thing. Where are they going to put it on this one? They're going to put it right here because that's the last thing they see. That's not what the student wanted it to be, but that's what they wrote. The dx closes it off. So write the dx. Okay. All right, enough. Okay. So we're back to this. We know that this first one here is 10. There's a little lag on this video, and it's kind of making me confused. All right, and then we have the integral from 0 to 3 of g of x, which we know the function for, 12 over 3 plus x. So now AP is asking, does this student know how to integrate? Does this student know how to integrate? Does this student know how to find an antiderivative? Okay, what is the antiderivative of 12 over 3 plus x? It is a natural log because the denominator is linear. It's a natural log. The 12, I'm going to have a 12. ln, absolute value, 3 plus x, close absolute value. The derivative of the inside is just a 1, so it's like we're dividing by 1. I'm not going to write that, but it is. If the derivative of the denominator was anything other than 1, you would have to divide by that. That's what you would get if you u-subbed. 0 to 3. So this is 10 minus 12 ln of 6 minus ln of 3. And I'm going to say stop right there. Okay, feeling good? I'm feeling good about part A. Let's go on to part B. Part B. Evaluate this improper integral or show that it diverges. Okay, so now we have the integral from 0 to infinity of g of x squared, and I know what g of x is. So 12 over 3 plus x squared. Okay, well, this is the same thing as 144 over 3 plus x squared. The 144 can come out. Like that. And now, is this an ln? That was an ln. Is this an ln? Absolutely not. It's not an ln because the bottom is not linear. Instead, we can think u sub, but if I let u be the 3 plus x, du is just dx. So I'm not going to actually do a u sub. I'm just thinking, what would I do if this was a plain u? And I'm going to get, okay, 144. I'm doing the antiderivative now, so I must write limit at this point. B is going to infinity. Okay, that's going to be u to the negative 2, so negative u to the negative 1, which is negative 1 over u, or negative 1 over 3 plus x, from 0 to b. So 144 times. Okay, put b in for x. B is going to be in the denominator, and b is going to infinity. The denominator is going to infinity. What is 1 over that going to do? It's going to go to 0. So this first piece, when we put b in, is going to 0. Minus a negative, now we're putting 0 in, 1/3. And we're done. That's it. We found the value of the integral. Part C. Let h be the function defined by this. Find the value of the integral 0 to 3 of h. So we want the integral of from 0 to 3 of x f prime of x dx. And we do not know the function for f. All we know is this integral for f. Okay? So how are we going to do this? By parts. U dv. By parts. X is going to be my first u. The derivative of x is 1. The derivative of 1 is 0. My first dv is f prime of x dx. We integrate all of our dv's. The integral of f prime is f. The integral of f is the integral of f. Yeah? I never write an integral without a d something. Okay? And now, plus, minus, plus, minus, plus, minus, plus, and we go diagonally. So this is going to be, all right, x f of x, and I'm going to go ahead and apply my boundaries to that. So x f of x, apply my boundaries, minus integral f of x, apply my boundaries. And that integral doesn't bother me because they told me that that was 10. So I am almost there. I'm going to have x f of 3 minus 0 f of 0 minus 10. This piece is 0. What is f of 3? Well, f of 3 they gave me in the problem. It's 2. So this is, oops, that would be a 3, f of 3. I'm putting 3 in for x. 3 times 2 minus 10. Okay, let's see how this was scored. All right, part A. 1 point was given for the integrand. And then 1 point was given for the antiderivative. And then another point was given for the answer. So integrand, antiderivative, answer. Part B. 1 point was given for the limit notation. Okay. 1 point was given for the antiderivative. And 1 point was given for the answer. So, limit notation, don't put infinity here. Take care of it with a limit. Antiderivative and answer. Part C, 1 point for doing by parts integration, u and dv. 1 point for, here's what they wrote. Integral of h of x is equal to x f of x minus the integral of f of x. So that was the step right here, yeah? So, of course, that was a crucial step. And then 1 point for the answer. So, I was a little bit wrong. My first thought was that this was going to be an area and volume question. There was no place in here that they asked me about volume. They did ask me about area, but no place in here did they ask me about volume. So, I can see why students did pretty good on this. Hopefully they could integrate. This was an integration problem. That's what this was.